Alright, number 1. A region is bounded by x squared, y equals 0, x equals 0, and x equals 1. The only place I see where that is that little triangular region right there. So I need to make sure the intersection points are correct, and I got 0 and 1. So part A, find the area. So that's just going to be 0 to 1, x squared dx. Find the volume if cross-sections are squares. So we got cross-sections coming out like this. So the height of each square is just the function squared. Okay. Next one. Cross-sections perpendicular to the y-axis are equilateral triangles. So that's going to be square root of 3 over 4 side squared. My y's go from 0 to 1, and my side is going to be 1 minus square root of y squared. So in terms of y, the x squared function becomes square root of y. Okay. Rotate around the x-axis. So let me move this out of the way. Oh, it's grouped together. Alright, rotating around the x-axis, I believe. So we take this region, going to draw my rectangle. Height of my rectangle is always x squared, so pi x squared squared. Okay, next one. Rotate around y equals -3. That's down here. So pi 0 to 1. Outer radius x squared minus -3 minus my whole 0 minus -3, top minus bottom. Okay, y equals 5. This is above. Obviously that's not y equals 5. So if I look at this one, the longest distance is actually to the x-axis. So it's going to be pi 5 minus 0, that's the x-axis squared, minus 5 minus x squared squared. Alright, now let's get these last 3 out of the way. I'm going to bring in the picture again. Alright, now we're rotating around the y-axis, x equals -1 and x equals 4. So y-axis, x equals -1 and x equals 4. Alright, so we're talking about this region right here. I'm going to draw my rectangle. The farthest distance is that right there. So right minus left, 1 minus 0 squared minus the whole, which is square root of y minus 0 squared. I know I don't need the minus zeros, but I'm just trying to show you right minus left. Okay, the next one, around x equals -1, it's over here. Same pattern. Right. That's 1 minus -1 squared minus square root of y minus -1 squared. And finally, around x equals 4. This time, the farthest distance is to the square root of y function. So it's going to be 4 minus square root of y squared minus the whole 4 minus 1 squared. Right minus left, outer minus inner. Okay, there's two ways to look at this one for bounding it by the sign, the line, and x equals 0. We could be talking about this small region right here, but I'm actually going to be referring to this region over here, the larger region. Okay, so we want to find the area of this region. So the area is going to be the integral from 0 to 1, top function, minus bottom function. Okay, the volume if cross-sections perpendicular to the x-axis are semicircles. So if my circle is laying on my function, that's the diameter. So it's 1/2 pi r squared. Well, r in this case is top minus the bottom. That's the diameter. Divided by 2 gives us the radius. And then we'll square it. Okay, part C, we're rotating this region around the x-axis. So if I have a rectangle, okay, it's the outer squared minus the inner squared. So it's going to be two plus 2 sine pi x minus 0 squared minus the whole, which is x plus 1 minus 0 squared. Okay, now we're rotating around y equals 1. So here's our line. Still have a hole. But you got to do top minus bottom. So it's going to be 2 plus 2 sine pi x minus 1 squared minus x plus 1 minus 1 squared. And then the last one, we're rotating around y equals 5. So that's above this curve. And if you're above it, the big distance is actually 5 minus x plus 1 squared minus the whole 5 minus 2 plus 2 sine pi x squared. We're going from 0 to 1. And don't forget your pi. Alright, for this third scenario, we have two quartic functions. They're pretty much the same one. The blue one is just flipped and then shifted up 2. We want to find the area of the region, but first you have to find the intersection points. Using a calculator, I got negative 1.132 and 2.132. Alright, so we want to find the area of this region. It's just going to be the blue function, which we're going to label these. Blue one's going to be f of x, and the red one will be g of x. So if I got them backwards, don't I? Let's try this again. We're going to call the blue one f of x, call the red one g of x. Alright, so the area is top minus bottom. Okay, the volume if cross sections are rectangles of height x squared. So whatever the x value is, here's one side of my rectangle, and the other side is x squared. So it's going to be f of x minus g of x times x squared, because it's base times height, and we're going from negative 1.132 to 2.132. Alright, find the volume when we rotate this around y equals negative 1. So you got the outer minus the whole, the inner. So it's going to be pi times the integral f of x minus negative 1 squared minus the whole g of x minus negative 1 squared, same bounds. And then the last one is we're rotating around y equals 4. It's going to be up here. So we've got the long distance is to g of x, so 4 minus g of x minus the whole, which is the distance from 4 to f of x. Don't forget our pi. And hopefully I remembered my pi down here. I did. So it's top minus bottom, outer minus the whole, the inner. Got one more problem. Okay, this one says the region in the first quadrant bounded by x squared, y equals 1/2 x plus 5. And it says the x-axis, but I'm pretty sure I meant to type the y-axis. So the region I'm referring to is this region right here. So the intersection points are x equals 2.5, and this is x equals 0, so that's not really an intersection. Alright, so part A, find the area of the region. It's the integral from 0 to 2.5, top minus bottom. Alright, find the volume if cross sections are triangles whose height is twice the base. Area of a triangle is 1/2 base times height. Here the base is going to be top minus bottom. The height is twice that, so times 2 times top minus bottom. I'm not going to rewrite it, I'm just going to put it squared. Okay, part B, find the volume if cross-sections perpendicular to the y-axis are squares. That's going to look like this. Okay, so it's actually pretty interesting. It ends up being two integrals because at this point right here, it changes from the squared function and the axis to the squared function and the line. So let's scoot this up. Alright, so between 0 and 5, it's just going to be square root of y squared, because we're talking about squares here, plus from 5 to the intersection point, which the y value is 6.25, is going to be the right minus the left, which the left in terms of y, 2y minus 10. These are squares, so right minus left squared. Okay, find the volume when the region is rotated around the x-axis. Okay, so I want to rotate that around the x-axis. If I draw a rectangle, clearly there's a hole. It's going to be pi 0 to 2.5. Outer minus 0 squared minus the whole. So we have outer minus the whole. Alright, when you're rotating around y equals -2, that's below. So it should be the same setup. Top minus -2, right? -2 minus x squared minus -2. Now we want to rotate around 5. Well, clearly this is a horrible problem because 5 cuts right through my problem. So maybe I misread it. Okay, if we want to rotate around the y-axis, so now we want to come around this way. There's two methods you can do. The first would be putting it in terms of y. The unfortunate fact is that if you put it in terms of y, you have a right minus left that's different than this right minus left. So it'll end up being pi times the integral from 0 to 5 square root of y squared for the first part, plus pi outer squared minus inner squared. Very much a pain. If you choose to use shell method, it's going to be 2 pi times the integral from 0 to 2.5. The distance to the rectangle is x, and then the height of the function is 1/2 x plus 5, top minus bottom. So that does make it a little bit easier. When you want to rotate around x equals 8, it's very similar. Let's see, x equals -8, excuse me. Okay, that's over here. So the setup would be very similar to this guy right here. The only difference, we're doing right minus left. So the first part would be right here, plus the second part okay, which would be outer minus inner dy. Again, all this can be replaced with the shell method. Your x values go from 0 to 2.5. The radius, x minus -8. And then the height, which is just a lot easier to write than that whole mess. Alright, and the final one, we're going around x equals 11. Same deal as before. If you write everything in terms of y in this particular case, it's going to be 11 minus, oh wow, okay, so let's go back up here. Here's x equals 11. Here's a rectangle. The outer is now 11 to the y-axis, and the whole is now 11 to the square root. So it's going to look something outer minus inner. That goes from 0 to 5 plus for this one 11 minus 2y minus 10 squared minus my whole. Oops, is it y minus, yeah, 11. Okay. Clearly this is not nice. Again, the benefit of the shell method is I can do 2 pi. My x's go from 0 to 2.5. The distance, my radius is going to be right minus left, 11 minus x. The height of my function is 1/2 x plus 5 minus x squared.